Okay, so we're getting here our Beyblade linear velocity measurements. You can see how I'm just holding this over some point on the top. I'm doing my best not to poke it into the top, but it does happen. We're at the end of the run right now, so our top's starting to slow down. Slowing down, slowing down, slowing down, slowing down, slowing down. It slowed down. Okay, cool. Don't do that, but time for the video. Okay, so what we should get on our LabQuest minis or our 2s is this kind of linear velocity graph at the bottom here. And from this graph, you should be able to get an initial linear velocity at the very top and a final linear velocity down here at the bottom, just by reading the graph. Okay, so you'll need to get those distances or those values for the velocity so that we can run some calculations. You should have already measured your radial distance to the dot on this, wherever you were measuring out, because that'll help us find angular velocities. You can do those conversions on the back of our best friend to get from a linear to an angular quantity, and that'll tell you your angular velocity. And that value of omega there, remember, is constant for every single part of the top. So it doesn't matter if you were measuring, from the inside or to the very, very edge here. As long as you know that distance, you will get the proper value of omega. With that value for initial and final, you can calculate an angular acceleration. What we're also going to do to calculate an angular acceleration is we're going to use this graph here. Notice that the y-axis is velocity and the x-axis is time. All the way back in unit, I believe 4, we had velocity time graphs. And we saw that by taking the slope, or if you want to do some calculus, the derivative of this graph, we could find the acceleration. So if we have here a velocity graph and we take the slope of it, we will get an acceleration out of there. We need to be careful though. That is technically a linear acceleration. So we'll need to do a conversion there to put that into angular quantities. That's what you'll need to do in the lab.